Now we continue our question further. We'll take one or two more cases. Let's say E part is the perpendicular distance of the line from origin is root 5. Now what are we looking for? Our line is passing through the point of intersection of the given two lines. X plus y plus 4 is 0 and 3x minus y minus 8 is 0. This was our two equations. I guess these were our two equations. Yes. Now our line, there are infinite lines that would pass through this point. There will be infinite lines that will pass through this point. But which line are we looking for? The line whose perpendicular distance from origin is what? Root 5. We are looking for that line. So what was our equation? We had written L1 plus lambda L2 equals to 0, and by writing this we had got x 1 plus 3 lambda plus y 1 minus lambda plus 4 minus 8 lambda was 0. This is a general equation of the family of lines. And which member are we looking for? Whose distance, perpendicular distance from origin is root 5. So how do we find the perpendicular distance from origin? Origin is what? 0, 0. So how can we find the perpendicular distance? We'll put zeros, bring every term to the left side, which is the case. Then put 0, 0 in the equation. Therefore 0 into 1 plus 3 lambda, 0 into 1 minus lambda, plus 4 minus 8 lambda, whole divided by 1 plus 3 lambda whole square, 1 minus lambda whole square, take mod, and this distance is given to be root 5. This is square root. Now this is 0, this is 0, and this becomes 4 minus 8 lambda upon this is this is 1 plus 3 lambda whole square plus 1 minus lambda whole square is, let's say, root 5. Now for convenience, what we do is we'll take this as, let's say, 2 root 2. We take this as 2 root 2 so as to make the question a little simpler. So this becomes, let's say, 2 root 2. So this becomes 2 root 2. Now if you look closely, we can take 2 out, 2 minus 4 lambda, and upon this is 1 plus 3 lambda whole square plus 1 minus lambda whole square. This 2 root 2, this root 2, 2 and 2 goes. Now what we can do, we can square it. So what we will get, 2 minus 4 lambda whole square is 2 into the square root will vanish, 1 plus 3 lambda whole square plus 1 minus lambda whole square. Expand this 4. In fact, we can take 4 plus 16 lambda square plus 16 lambda is equal to 2. 1 plus 9 lambda square plus 6 lambda plus 1 plus lambda square minus 2 lambda. We can divide 2 throughout, therefore it becomes 2 plus 8 lambda square plus 8 lambda, 16. And this is 9, 1, 10 lambda square plus 4 lambda plus 2. We can rearrange, take all the terms to right hand side. We have 2 lambda square, then we'll have minus 4 lambda, and 2 and 2 goes, is 0. Therefore 2 lambda is common, lambda minus 2 is 0. Therefore there are two possibilities, either lambda is 0 or lambda is what? 2. Again, therefore two lines are possible whose perpendicular distance from origin is what? Root 2 root 2. Therefore we'll substitute these values. Again we find that lambda is 0, therefore we'll get back our first equation. Therefore x 1 plus 0, y 1 minus 0 plus 4 minus 8 into 0 will give us 0. That is, we get back our first equation. This equation is satisfying both the conditions. It is passing through the point of intersection of both the lines. Obviously this is the line itself, and its perpendicular distance from origin is what? 2 root 2. The second equation that is possible is when we put lambda is equal to 2. Therefore x is 1 plus 3 lambda, which is 6, plus y 1 minus lambda, 1 minus 2, plus 4 8 lambda. 8 lambda means 8 to the 16. Therefore 7x minus y minus 12 equals to 0. This is your second equation which is possible. Therefore the answer to this question is this. Let's take one more part. Let's say the line makes equal intercepts. The line we are looking for is makes equal intercepts. Makes equal intercepts with the axis. Now this we have already discussed. If a line makes equal intercept with the axis, its slope is what? Minus 1. And what is the slope of our line? 1 plus 3 lambda upon 1 minus lambda. That is, we are looking for that member of our family which makes equal intercepts with the axis. Therefore minus goes, 1 minus lambda is equal to 1 plus 3 lambda. This is 4 lambda equals to 0. Lambda comes out to be 0. Again we find that we are getting back our first equation. X 1 plus 0 plus y 1 minus 0 plus 4 minus 8 into 0 is 0. That is x plus y plus 4 is 0. That is, the line that was given originally is satisfying this condition. It is making equal intercepts with the axis. It is making, and you can very well see what is the slope of this line. Minus coefficient of x upon coefficient of y. What slope is it making? Minus 1. Therefore definitely we are getting back our first equation. This is the equation that, as we had said earlier, we can get back our original L1, but we cannot get L2. Whatever we write, whichever equation we write with lambda, we will not be able to get that equation. The first L1 part we can get back. I hope you have understood this topic. It's very important, family of lines through the intersection of two lines.